Well, I'm back again now looking at the Nema 23. We're winter time now, short days, long nights, so I need something to be pottering around with. I did some tests, field tests with this last year. One day there were moderate winds, but it was promising. But other events took over during the year, other projects, so I'm only now getting back to it. So one of the issues I had with it is that it was quite heavy. I actually measured it there, 2,450 grams. So I looked at it and see is there anything I could do. I shortened this end cap, cut it in roughly half. I shortened the stub pipe inside, that reduced a bit of weight. And then I said to myself, well, there was no need to have this cap on the other end. It's quite a bit of weight, and I shortened this as well. And also this, the length of this, I reduced it. So with them mods, my new weight now is 2,100 grams. So I reduced it by 350 grams. Now it's still heavy enough. The only thing else it's done, of course, is it's made it tidier. I've knocked about 40 mil, inch and a half over the length, so it's as neat as I can get it. And as I say, it's a bit lighter. So when I finished that, I started looking, is there anything else I can do? And rummaging around with my bits and pieces. Exhibit A. I had this again from a turbine I don't want to talk about because it never produced anything. But if I can use any bits off it, well then maybe it's a bit of profit. So that fits nicely on the 1/4 inch pole, and you can clamp. And it had this. It's just cheap casters, caster bearings, but yeah. So again, a bit of timber to adapt to be able to bolt this onto that. And I did have, sorry about the angle here now, I did have a Nema 23 bracket from the previous time, which I never used. So I said, right, if I can mount the bracket there, put the motor on, it's keeping everything quite in line with the center line or the fulcrum. No, not that much overhanging weight, and it should be lighter. So, and again, just using the action cam brackets for the tail fin, that works out well for me. You know, it's the one with the three lugs. So if I flatten a bit of copper or a bit of aluminium I have, it stays there, it doesn't drop down, and this clamps it in. So that's the standard I keep now, and it means I can move the tail fin between one and the other. It's a standard part. So I think this will be a lot lighter, relatively speaking, and a lot easier to mount, and it's a tidier, it'll be a tidier unit. But I didn't want to be butchering this to get the 23 stepper out of it, so I went away and purchased another one. Actual fact, the same one. I got it off Amazon, I think. Is it there? Look, you can pronounce that yourself. I got that because it's 2.8 amps, but it's low torque needed to turn it. Well, relatively low torque. There's ones at 4 amps, but they need a hell of a lot of torque. You probably need blades over a meter. So it wasn't very expensive. I think less than 30 euros. So I decided I'd get that, keep the other one intact. Then I've never used these, but I decided to try these rectifiers. Up to now I've been making my own. Now I couldn't get anything smaller. What's that, 25 amps, 400 volts. I was looking around for something maybe be 5 amps, 100 volts, but I couldn't, I take it they are somewhere, but I couldn't find them at the time. And again, I don't want to be waiting a month or more for anything to come in from China. So PVC electrical box, and I'm going to mount 2 of them in there and a couple of capacitors and bring in the cables and out. And yeah, I don't think I'm going to have a problem with heat. There's a bit of a gap there anyway, but I'm not going to be producing that much energy that I need to have a heat sink, so I'd say I'll get away with that. There is a slip ring inside of this. That's another reason I want to use that, because it has a slip ring. Cables are there. So there are the 4 cables on the 2 phases. There'll be, so I'll connect them to these. So this time there's no room to be putting the diodes or that up there. They are inside that one. So I'm going to run from the stepper motor through this slip ring, and I purchased 10 meters of this cable here, which is my angles are 4 square 0.75 millimeter square cable. So I'm going to connect there is an end cap and a gland there, and run it down and connect into the bridge rectifier system down closer to the leisure batteries. Because one of the things is with the conversion from AC to DC in here, I have to have a long run of about 10 meters of cable to get to the batteries. So I just want to see whether bringing the AC closer before I rectify, closer to the leisure batteries, whether that will make any difference to performance. You've got to love the Chinese for specifications. They have this boy down as 350 grams. Let's see. Right, let's see what we're getting for nearly 700 grams, twice the weight. Yeah, you gotta love the Chinese for their specifications. I knew it was heavy because the other one is heavy. Yeah, so we'll see, we'll put it all together, and this video is probably going to be long-winded a bit now, and we're coming up to Nullig, Christmas time, and that brings other priorities or duties, shall we say. So maybe when Christmas is over, I have this boxed up, and a day there's a reasonable bit of wind, I'll give it a field test and compare this one, the new one, to the old one under similar conditions, and see is there any difference in performance. But I do expect a reduction in weight, because looking at that lot there now, put her on there and just stick that one up there for now. What are we getting? 1116. Alright, there's a few more bits and pieces to go on, cap and that. So we'll say it's probably going to be somewhere around 1200 grams, probably 900 grams less than the modified. Now, if anyone wants to convert from kilograms to pounds, you multiply a kilogram by 2.2. There's 1,000 grams a kilogram, so that's 1.116 of a kilogram. Multiply that by 2.2 and it'll get you to pounds. Right, I've this bit done now. I've run the cable into this gland system here. Yeah, so that's for the pipe, so that worked out very well. I'll have to tidy up these cables. Some are there for now. And as I say, if it works out, I'll probably put some sort of a cap over it. But that's fine now. That part is done anyway. Next job will be to sort that out. So I just try to make sure all my wiring was correct. I did check the continuity of the Nema 23, as per their sketch, so the black and the green, positive and minus of that phase, and the red and the blue. So because I had 6 cables for the split ring, I decided on the positive to put 2 and 2 onto the positive, and then just on the negative return 1, rather than just using the 4. And then came down here and connected up to the four cables then on the long cable. That's what I've done so far. Right, this is now connected. It was a tight fit. I could have done with a box that size, but I didn't have them in stock. So yeah, that's it now. So I'm coming from the turbine, through the cable into the rectification, and there are 2 capacitors in there as well. Out of there then to in SAE over to my buck converter, because this thing, these turbines can go up to 45-50 volts, so I just have and from there then it will go to battery. So that's the configuration. Okay, I'm just going to use a battery drill. I've already tried it at 400 like previously, and you don't get anything. But once you go over 400, she starts to generate. This battery is nearly full. Now I'll try and do this with holding, but because I have to hold the turbine as well now. Right, here we go. It's not my hand, it's just trying to hold everything. Yeah, so she can charge, and as I said, that battery is full now. If it was down at 12 volts of that. So it's promising. Now, if anyone's interested and is making one of these or similar and wants to get this 3/4 inch mount for a pipe with a slip ring, with that swivel type bearing, you can get it from this Cutting Edge Power. So you can buy the just the body without the DC generator and without the blades. You can buy these little hubs either for 3 or 5 blades. I have it set up at the moment here now with the 5 blades, but I also can change over to the 3. Now for mounting, I just went and got one of these collet type things that they use for model airplanes and that. I just got one that suited the shaft diameter, which I think is 6.35 millimeter, which I think is probably 1/4 of an inch imperial. Now I think this Cutting Edge have a different arrangement now that comes with these. There's some sort of a collet, but you can look up their website if you're interested. It's a bit difficult to find. I think you have to go in and look at down their menu of accessories or extra parts, and there's pages and pages and pages, but you eventually, if you're interested, will come across this and the blade and the hubs. Yeah, okay. Now if you do get it, you'll just have to remember that this was set up for a DC motor generator, and there is a blocking diode on the end of the wiring, quite small, and if you were going for something like this, you'd have to cut it off.